Welcome back to the Amusing Greg. I'm in the process of pulling together a review on some iTechWorld lithium batteries and possibly their battery monitor, and I'll include a link here when that's done. But in the course of my testing, I came closer than I ever expected to starting a fire inside my caravan. So I wanted to share this public service announcement, if you like, ahead of the rest of the review, just in case you're planning a similar installation. Now, my van came with two AGM batteries wired up in parallel with some thick-looking cable, and a standard AGM battery charger to keep them topped up. I chose the iTechWorld batteries because they claim to be able to be charged from almost any regular 12-volt charger rather than needing a dedicated lithium charger. Now, this is something I'm definitely going to be testing, so stay tuned for that review. The idea here was that I could keep everything else in the setup the same and just swap the batteries. Nice and convenient, so I thought. So here's a setup with the original cables. These are 4 AWG cables that run between the batteries. Looks like about the same thickness, maybe even a bit thinner. That's going from the battery to the inverter. Obviously the ones that came with the inverter, these are nice really thick ones. So we're going to see how these cables perform once we start putting them under load. So nearly a kilowatt the air conditioner is using now. So drawing over 80 amps in the batteries now. So for each battery, the front battery 12.45, back battery 12.41. Between the interconnectors between the batteries, 0.3 of a volt on that one, 0.25 of a volt on that one there, and 0.17 of a volt on this cable here. Now I can't get to both terminals in the inverter, but I can get to them on this end here, and instead of having 12.42 volts, we've actually only got about 11.8. The reason this happens is that every copper cable has a small amount of resistance, and the more current you pull through a cable, the more voltage you lose between one end and the other. Check out my series on Electronics the Basics if you want to know more about Ohm's law and how this all works. So dropping 0.7 of a volt between the batteries through the cabling. I should mention that now we're drawing just over 100 amps. Okay, so we've got the air conditioner going and we've also got this blow heater going on low, and those two together we're now drawing 160 amps, nearly 1900 watts. So if we compare our battery voltages here, battery itself is sitting at 12 volts, just over 12 volts. On the inverter, the power going to the inverter, it's below 11. So we're dropping over a volt just through all the cables and connectors. So what do we got here? 0.37 of a volt on that cable there, 0.37 there, nearly half a volt there, and nearly 0.2 of a volt there. So this means that because that big inverter is drawing so much current, not all of that juicy lithium battery power is actually getting to the inverter to do useful work for me. What a waste. But where's it all going? Now the other problem we've got here is not just voltage drop, it's also heat. Now you can't tell this, but I'm going to show you in a second that these terminals are getting very hot. This one here in particular. Let me show you. Okay, we've got a temperature probe on our multimeter. And let's put this onto each of these battery terminals just so you can get an idea of what we're dealing with. Over 60, look at this, over 60, close to 70 degrees. And that one there. This one over here. Look at that. That's basically boiling temperature. Over 100 degrees. This one here, a little bit cooler. Wow! I can feel the heat just with my hand there. 111, 112, 113 degrees. Wow, I can actually, this actually feels really, yeah, that's actually really hot to touch. Just in that cable there. Look at this. Check this out. I'm just over 100 degrees. That's actually going to catch fire if I leave it like that. 140, 150 degrees. Look, it's actually, I can actually push the probe through the insulation. That's how hot it's got. We've got to get this off. We've got to turn this off straight away. Otherwise we're going to start a fire. Wow. That is amazing. That is so hot. And those terminals are tight as well. That's... wow. You'd boil an egg on there. Wow, that's amazing. I can't believe that. These ones here, the ones that came with the inverter. Well, let's check those out just so you can see the difference. I mean, they're warm, but they're nothing like the other ones. From the installation. Nothing to be concerned about there. But these ones here, there's no way they're up to the job. I've got to say, I mean, I'm filming this and I knew they were going to get hot, but I've never run the inverter that hard and I had no idea they were going to get this hot. I'm actually a bit scared now that I could have potentially caused a fire by just running these. I think, that's still actually really hot to the touch even now. I can't believe that. I mean, I'm doing this video to make the point that you need to make sure you have the appropriately thickness cable, but I had no idea it was actually going to get this hot when I started to load it up. So these are the cables I've got to replace it. They are OO gauge cables. Got them made up at iTechWorld. Cost me just under $100 to get these made up, which I reckon, considering the thickness of these cables, pretty happy with the price of those. So let's put those on. Alright, we've got a nice thick cables installed now. Let's see how they go. Alrighty, we've just started the air conditioner up, and the heater, we're actually drawing over 2000 watts, so 170 amps we're pulling. Let's come and see what the voltage drop's doing across that link. Wow, look at that. 0.029, so 29 millivolts. That was 0.3 of a volt before, now it's 0.02, so it's 1/10 of the voltage drop. Let's come and have a look at some of these other spots which we had. So, main voltage is sitting at 12 volts. That's at 12 volts. That's just the fan on the inverter started up. On the interconnector, we're dropping 0.01 of a volt, 0.02 of a volt. So on the inverter itself, about 11.6 compared to about 10.9, which is what it was before, and we're actually pulling more current now than what we were in the past. Wow, well, we've never pulled this much power before. Nearly 2500 watts, over 200 amps coming out of the batteries now. And that's the reason why the iTechWorld 3000 watt inverter, which you can see sitting in the back there, has started the fan up. This terminal here, this was over 100 degrees before. It's now 28, 29. And remember, we're drawing more power. Over 200 amps is coming out of these batteries at the moment. And there's just no change in temperature. Nothing significant there anyway. The cable feels slightly warm to the touch here. This definitely feels warmer. I can't feel anything on those. That's the only place I can feel warmth. So let's check how warm that's got now. Yeah, so it's getting there, 54. But on our new interconnectors, only slightly above body temperature, which is fine. So the moral of the story is, if you're doing any high current mods like installing a large inverter, a bigger battery charger, or a more powerful solar panel, replace any cables that'll need to take a lot of extra current. It probably won't be all of them. I only had to replace 4, so it doesn't have to be a big or an expensive exercise. But chances are your old cables were only thick enough to carry whatever they were originally designed for, and if you cheap out and try to reuse undersized cable, you'll not only lose a good portion of that power you've just paid for, but you could end up in a world of fiery trouble. Wow! As to how thick they should be, well, that depends on how much current you're going to be drawing and how long they'll be. There are lots of different charts available online, but I found this good calculator over at solarforrvs.com.au, which calculates cable sizes for all aspects of your 12-volt system. You scroll down and you find this kind of daunting looking diagram, which is how it looks initially, but the basic idea is you just find the component you're installing, which, like, you've got a mains charger here. This one here is supposed to be for an inverter, but unfortunately it's not labelled. And you just type in the size of whatever it is you're doing, like a 3000 watt inverter, and how long the cable's going to be. Let's say it's going to be 3 meters. And then it tells you in this purple box what the thickness of the cable is you need to use. Now, as you can see, depending on whatever you select, you know, the cable's going to drop in size. It's not always the same type of units they're using, like a 2 BNS. I mean, what on earth is that? Look it up on Google. You know, you'll be able to work out how to convert those to whatever units you need to work in. But it's a pretty cool little tool that you've got to be able to pretty simply work out what sort of thickness is recommended. And it also tells you what percentage voltage drop you're going to get in the cable by using those. And obviously you can do the same with mains chargers, DC to DC chargers and so on. It's a good way for calculating the cable thicknesses for your whole system. So I hope that all helps to keep your installation safe. Please like this video if it's helped you, and make sure you subscribe so you get notified when the full iTechWorld battery review goes live. But that's all for now, so I'll catch you next time.